maybe if you feel like htop as well. A
Hello?
little cleaner interface, but basically the same things
Start from the
and
time
can be
mute
modified
button.
if I remember. Oh no, wrong button. So one of the few things that I'd like to talk first is load averages, a very basic parameter that we need to look on for in Linux administration. But do we all know what it means? Any one of you? Hello.
Yeah, yeah, can hear you.
Okay. Yes. Please go ahead. So load averages. We're talking about load averages. Anyone has an idea on what load averages represent?
Yeah, what is the load on your CPU, or how many cores you have, and on basis of that you can differentiate, like, is it high or not, and it gives you 5 minutes, 10 minutes, and 15 minutes. I mean, means 5 minutes gap is there. So three parameters it will show there.
Mm-hmm. Almost,
Yeah, you can take it.
not.
Uptime also will give the same result, but top will also give the same result, I think.
Yeah, it's basically fetched from the same file system kernel utility on the proc directory. But yes, it is done the same, almost right, but not quite there. Anyone else? Hello, anyone? Come on, guys. It's not a like shaming session or it's not a like a assembly. It's a init session and you guys need to talk. Hello.
प्रथम क्वेश्चन क्या था?
Load averages, what do they actually display? What does it actually mean? When you see 0.74 or 0.25 or 0.24 in three columns, what does it actually represent? Okay.
Maybe in a column of I can see CPU percentage and memory percentage.
No. So if you see right here, right, where my mouse is, it
Okay.
says load average, right? One of the very basic system administration Linux things that every DevOps I feel should know because it essentially tells you what kind of system CPU health it is going on, and not essentially CPU only, just CPU. It can also dictate how your memory is, how your disk is performing, or how your cache is performing as well, depending on the situation, of course, but primarily CPU. So, Sachin, you are allowed to speak.
Okay. I believe like I've been used it last like not continuously, but to my
Mhm.
remembrance, like it's a load average of your CPU in milliseconds based on the time intervals. It's like 5, 10, 15 as
Yeah, but
such.
what does load average actually mean? How do you actually read it?
You
Tell
might
her,
be.
tell her.
I think
It's okay.
that totally depends on vCPUs, how many vCPUs you have on your host. So
Definitely
if it is
depends on
point
the
0.1,
CPUs.
yeah,
Mm-hmm.
yeah. If it is 0.15 and you have a one core CPU, then that's also good. But if it is going more than one, then that is something wrong with means your system, or yeah, there is load is high on your system basically.
Mm-hmm.
So yeah, if it crosses the one point something, if it starts coming, then it is not valid for one core CPU. Then you might need to increase the CPU cores.
Correct. It's a basic premise how you know actually read it, but not what it actually means. Depends on the vCPU. That's another point that like you have added. Definitely there, but doesn't get the full picture. Dragged it on for 8 minutes or maybe seven. Let me just like make it a little more clear. So if you can see clearly, I don't know if the codes are available, like visible. Is it?
Yes.
Oh,
Yes.
okay. Let's assume, first of all, load averages come in three time frames. It's 1 minute, 5 minutes, and 15 minutes. So Sunil, it's not 5, 10, and 1, 5, and 15.
Yeah, yeah, got it, got it.
Yeah, right. And the actual frequency of the loads that are measured is in milliseconds. That's true. And it's an average of the whole load in 1 minute. But what it actually means is how many processes or how many like executions are going on the CPUs as of now. So since it's a 64 core machine, you see a 0.64. There's basically no load. If you can see very properly, very few cores are being used. You can visibly see. But let's take an example of a single core or a dual core processor. What would it mean if the load average was 1? The load average 1 would indicate that one of the cores of a dual core system is actually processing and doing something, and it's still doing it for a minute at least. And sorry, and the other core is essentially idle. Sorry, that would be in a single core processing, not dual core. I'm so sorry. In a single core processing, and when it goes to dual core, it will become point 0.5 essentially, saying one core is idle and the other core is running. One process or process is waiting for the core. And as it goes on, if you go to 4 core system, it becomes 0.25. That means only one core is there, and if two cores are being used on the process are queued essentially or waiting for the process to complete, or another process is just hogging the CPU for 2 cores, then it would be zero point 0.5 in a dual core system if it's on 1 minute. And if subsequently if the 5 minutes also shows those things, it's actually bad to be honest. But it essentially means the same thing on a 5 minute average calculated on a millisecond basis. Now, how do you actually make sense out of it? So, getting a load average on small machines, maybe let's talk in terms of cloud, or maybe in terms of local machines as well, doesn't matter. If you have a dual core or a quad core machine and you see load averages hitting 1, that's not such a bad situation depending on other configurations of your machine as well. Because you have to consider what kind of process you're running, how much memory it's consuming, and how much, like what kind of disk is behind your system. If your disk is slow, like an HDD, and it doesn't have a throughput enhancement enabled, then essentially it can be lagging behind in read and write IO. That's happening, and the process that is getting actually executed on the server on the CPU core that is waiting on simple IO to be returned from the disk. It might not have enough memory, so it needs to shuffle a lot of data from disk to memory and then memory to CPU. Cache comes in a lot less play, but it's the same thing with the cache and the memory as well. So if your cache is not fast enough, that this rarely happens in current modern generation systems. But if older systems are to be considered, we used to have 512K cache or 1 MB cache and a single level of cache as well. Right now we have like 3 levels of caches and things go pretty much very fast now. So depending on the situation, if your disk is good, if your memory is good, and you see load averages like hitting 1 or 2 or maybe even above, it's a sign that either the process is doing something wrong or it is simply stuck and maybe in a deadlock or maybe just stuck, nothing else. And one of the ways that you can see if it is stuck and not assigned to a parent process would be to check its PID and the parent process. If the PPID is 1 in that case for the process that is actually stuck, it would mean that the process has been abandoned and it's just running without any parent process, and you can essentially kill it to free the system resources and get rid of that space within the CPU. So any questions on this part? YOLO.
No.
Can you come again on the load average? Like, how load average calculates, how we can calculate the load average.
Yeah, yeah, sure. So let's say, well, let's start from a single core system, right? Load averages, let's take for 1 minute. Let's start with 1 minute, the first load average that you see.
Okay.
If one core system, one process is running or is in queue for the process, it will show one, right? Yeah, that means one core is essentially being utilized or has to process something, and
Okay.
it doesn't have much space or much time to do anything else. When you move to a dual core system, let's say you have two CPUs right now or two threads, as in case of most virtual machines right now, then a value of 1 would essentially indicate all your CPUs are there. But if one of them is being utilized, it would be zero point 0.5. And zero point 0.5 means one of the cores is idle or one of the threads is idle essentially. And subsequently you go to 4 core, 16 core, and some other things as well. So it's based on the processes that are waiting or being processed on the CPU core and how many cores or vCPUs you have. I say cores and vCPUs separately because cloud systems essentially operate on vCPUs unless you go bare metal, and a different types of capacity reservation as well in terms of AWS. If I'm speaking, not sure of the term for GCP. I guess it is capacity reservation as well. So vCPUs are single core, like a thread within a core, and core is a single physical core that can have two threads. So I'm referring to them separately.
Okay. So in my system, I am having 8 core CPU, and
Mm-hmm.
I can see the load average is for 1 minute it is 1.24 something.
Mm-hmm.
Uh, uh, is that mean I am using the all 8 cores of my CPU?
No, that doesn't necessarily mean. See, that's the trick of it. It's a load average. It's over a span of 1 minute divided into, like, calculated on the basis of millisecond. Let's say if you have an 8 core machine and the load average for 1 minute says 1.2 or something, right?
Okay.
It doesn't necessarily mean that all of the CPU cores are being utilized over the span of over the span of 1 minute.
1 minute. Yeah.
It can be one core or maybe just two cores being utilized over and over again,
Okay.
right? That's a load average. That's why it's in average, always in average. That's why it's very necessary how to know how to actually read it and understand it. As you saw on the system here itself, it went to 0.79, but none of the cores were being fully utilized. Not even one core was being fully utilized. It didn't mean that it had like a full consumption. It necessarily essentially means how many processes were waiting over the period of 1 minute for a core. So it can be one core over and over again. It can be two cores over and over again in a less frequent manner over the minute, or it can be all the cores at once and then not utilized, and that will create a load average of one as well, but not necessarily for the full minute. A
Okay.
little confusing, I believe. I know. I know it's a little confusing because I've seen things. I've dealt with ML systems that have consumed a lot of CPU power and load average is short of more than two. That didn't really mean that all the CPUs were utilized for over the minute and two processors were waiting in the queue. It can mean other things as well. That's why I say it's completely situation based how you read it. So if you can see, right, I'll tell you about the system that is on the screen right now.
Mhm.
So it is 64 core. It's a very big system and a 1.8 terabyte memory space. So we can expect there is no lag of I/O because it's a very high throughput disk, very high on IOPS as well, good memory, good CPU. But we see load averages spiking. One of the reasons is the license of the software that you're using, KX. It's limited to for 16 cores, as you saw, the spike. Some process kicked in. And you'll see the load average spike as well. Good example, man.
लोड एवरेज स्पाइक कैसे किया?
See, that's the thing. It's an average of all the cores. The first 16 cores are licensed for this software, so it's hitting the 16 cores over and over again.
Okay.
So if one CPU, vCPU is being processing like executing a process or waiting on a process, it will essentially make the other process wait in queue, right? It doesn't mean it held it on for 1 minute, but on an average, 8 processors were waiting within the minute on a millisecond basis for the 16 cores, or every 2 core one process. At least 8 means that. A little clear, maybe.
हाँ अभी थोड़ा क्लियर. एंड आई वाज थिंकिंग कि अपने अभी कोई प्रोसेस चलाया है क्या?
No, it's an automated process that we have set up. It's reporting time essentially. So reports are getting kicked off, and it's a very huge uh, disk intensive and memory intensive, and as well as CPU intensive work. So CPU usage is high at times in those reports, but it's mostly data and memory intensive. And you didn't see a memory spike as well, because we'll come to that next part. Okay. So any questions on load averages, or we can move? Okay, let's move on. Next, we'll actually discuss memory. There's a lot I want to discuss on memory, but let's see if we can do it with free. Okay. This is a minimalistic display of memory. And
Please.
sorry,
Human readable format, please.
more readable? Yeah, it is.
Okay, yeah.
Better now?
Yeah.
Okay, awesome. Thank you. So memory, if you can see, it says total use, free, shared, buffer, cache, available. It's a very basic usage, and when you generally see what you see, okay, how much is used, how much is total, and do we actually take a look at other things as well? This doesn't give the full view of it, that's why I was on top, but let's take to top and then explore. Okay. If you see simply the memory, it says 613 gigs occupied out of 128 that is currently being utilized. It doesn't mean it is not reserved, it is not sharing, or it's doing nothing. It's just saying that 1613 gigabytes of memory is being utilized. It's a very eagle eye view of the memory utilization essentially, but still it gives us some idea how the system is doing. But let's go to per process. If it's a per process thing, we see three major columns in regards to it. It says virtual memory, resident memory, and shared memory. Right? So, which one do we look for? Is it the virtual memory that's actually taking in the account of the 1613 gigs utilized, the resident memory, or the shared memory? Anyone? Hello?
Sorry, could you come again, please?
Yeah. So virtual, resident, and shared. Three kinds of memory displayed per process in top or htop, whichever you prefer. What column should we be looking for, and what column represents the actual memory utilization
What we
that
can
is
do
displayed here?
is
अरे कोई तो बोलो तुम लोग DevOps वाले बंदे हो. You people are DevOps. Speak.
Continue. We'll listen.
You want to listen?
Continue.
Oh, okay.
Can you run free? Then that would be clear.
Okay, I'll just scroll up a little for you to see. Yeah.
Okay.
Mm-hmm. It just
So
says
use it
there.
used it 612 and free is 332 GB.
Free is 232 GB. Okay.
Yeah.
If used is 612 gigabytes, how is 232 gigabytes free? I have a 1.8 terabyte system. That just like calculates up to 800 GB, not even 800, a little less than 800.
So it is actually the available one that is there.
Available, yeah, correct.
Yeah, the free and the buffer cache combined, and then it's give available one.
Okay. Then what is buffer and free?
So buffer is the available for caching.
No, it says buffer slash cache.
Yeah.
It's not buffer is not for caching. It's a different purpose.
So
See,
it's actually that Linux system automatically reserves some of the memory. That is cache. You can clear it and it will move back to main memory.
not exactly close, but not exactly.
But we can clear the cache, correct?
Yes, we can definitely we can clear the cache. Bad idea, but in terms if the CPU like if the system is going down because of cache memory, then definitely clearing the cache would help. But buffer and cache stands for something totally different. And everyone left the shared column as well. What's the shared? And what's actually resident, virtual, and shared memory?
Shared is basically the memory that is shared between multiple processes.
Yeah, why it is being shared between multiple processes, and if do we see a very big spike if we have a lot of processes like I have right now, or would we not?
वही वाला आप ही बता दो.
Right, there you go. See, it's more of an enhancement and enrichment session. मेरा मुझे कल से पता ही नहीं था कल से पहले कि मेरा ऑप्शनेट है तो मैं अच्छे से प्रिपेयर भी नहीं कर पाया लेकिन I went to a very basic thing that every DevOps person should know, no matter how experienced, no matter how new. And my workspace is glitching up. Let me see. I'm on good
ये
internet.
ये बंद हो जाता है तो फिर बंद हो जाता है ये.
No, it's
मैंने
okay. It's
मैंने इस पे किया
completely.
है ना.
I know.
लास्ट में इस पे था.
Yeah. So let's use my system. It says the same thing, but a fewer, like much fewer memory and much less cores. So let me pull up free. Stop. And we scroll a little up. Can we? Oh, it doesn't. Oh, it's so bad. Oh, we're back. So let's go over virtual residence. So resident memory is something that the process per process. So let's say if we're looking at PID 22598, right? Let me just add one more column and then we can proceed. Need to just create Does anyone see PPID? Yeah. F5 is add it, did I, yes, left, right. Mhm. Okay, got it. Oh, come on. Mm-hmm. Why is it wrong? Why? And let's try. Yeah, we have PPID. Okay. So resident memory is the memory that is actually being used and reserved, not actually reserved, actually being used by the process on the physical memory. That 76.9 gigabytes that you see,
Mhm.
22598, is the actual memory this process 22598 PID is utilizing on the memory sticks per se.
Hmm.
Shared memory and virtual memory are a little different things. So shared memory, as you said, partly correct, yes. Shared memory is something that every process utilizes, and it's a common resource that multiple processes might be using, and it needs to be in the memory, and that same memory space is being occupied, like utilized by all the processes, or some process and some processes utilizing other shared memory space. In our case, in the case that you're seeing, when you see scroll down, you see other values as well. So if we see this process right now highlighted, it says 5844 bytes per se. 5844 bytes of shared memory space is being utilized by the process. And the next one says 8108. It's a different, it can be a different part, but definitely it has parts that are different on the memory block, memory space, that are being shared with other processes as well. It can overlap with the 5844. It might not overlap with the 5844. You'll have to dig in very deep for that. So next is the virtual memory. Virtual memory combines everything. All the memory that is actually being utilized by a process on the system, whether be it shared, whether be it resident, anything. UCC 126 gigs.
Mhm.
That is like nowhere near 68.9,
Mhm.
right? What it essentially means is that this process might be utilizing, so 68.9 and 5844 is on the screen, but it might be utilizing another 60-70 gigabytes or so in the memory space with another system, or might have a space reserved. So it might have like another 60 gigs reserved on the memory space so that it can actually increase its utilization. And after hitting that virtual limit, it's upon the system's configuration how to deal with it and what to do with the process. In most of the times, if virtual memory limit in terms of buffer is actually reached or breached, the init process essentially kills it. That's how it's programmed mostly. But depending on the use case, it can just trim down the memory usage and free up some space and use on disk rotation of memory and swap spaces as well. They're like very rare, but can be done.
Okay.
Again, now let's go to free, right? Now this will make more sense. Oh, I forgot the H. Come on, dude, don't laugh at me. Okay, so total we understand, used we understand is the resident memory use up, and also includes the shared total of what's being utilized. Anything that is on the memory is actually in use. It can be shared pages, it can be a processes, mapping tables, that is mapping to the data on disk for that process, that is also being included and used. But it essentially accommodates all the parts of the memory. Free Free is an interesting column because it doesn't necessarily show us how much memory is free, not being utilized essentially, but it shows us how much memory is completely available. It is not in buffer, it's not in cache, it's not being held, you know, by a process that I might increase to this much limit. No, that 231 gigs is completely free and it can be allotted to any program and anything.
Mhm.
Buffer and cache are different things. So buffer is essentially a memory reservation that if we talk in terms of like naturally how DevOps people operate, right? We want a buffer of some CPU, we want a buffer of some memory in our containers, in our servers, and in our machines. Even if we go to our like living spaces, we want some wiggle room that we can move things around. That's a buffer space. That's an additional space that we might need, but we don't use it instantly. But it is reserved and it is told that okay, this space might be used. Please keep it for me. Don't let it be used. That's why it doesn't show up in free, and that's how you come to free plus buffer cache is equal to available. And cache is a little tricky. So depending on how you're looking at it in terms of processes, in terms of maybe disk mappings, it's per process if that cache can be used. So if 1.1 terabytes of cache is being utilized, it might have memory mappings or it might have read ahead tables or read ahead data of the system. So let's say if I'm doing ls on home, right?
Mhm.
A very bad example indeed, but let's go with it. If you're doing ls on home and there's a read block dev setting, let me see if I can put it. Get array, was it? No. Read it. Oh, it's double height. Hmm? Did I write it wrong? Oh, no. Hmm. Am I writing this right?
Read only, right?
ये क्या
Uh,
कर रहे हो?
Get
huh?
FRA.
Get size? नहीं,
No, no, get FRA.
no, it says GETRA only. But let me just try. Oh, it is. It says version.
Mhm.
Oh, there are multiple devices. Oh. Sorry. Forgot. Let me just do a quick BLK and
Let's
maybe
do that.
we. Sorry.
No, nothing.
Okay. Hmm. Let's say maybe I can pull it up now.
That's the mount point.
It is a mount point. I haven't used this in quite a while, so struggling with it now.
Okay, no, I don't even remember.
Okay, okay, got it.
Yeah, that's what I was asking. You are on mount point and the block is.
Yeah, yeah, block device. Okay, so let me clear it up and maybe we can start. Okay, right. So let's say we are doing ls home, right?
Mhm.
And our read ahead value is 8192. So essentially, let's say 8 KB
Mhm.
if it's in terms of bytes. And what read ahead does is actually pulls in data further ahead of what you're actually asking for. So it doesn't do it with ls, but I'm just giving it as an example so that people can understand. So if I do ls home, it might go in. Give me a moment here. So it might go into EC2 user and do ls and fetch the results prior to us even asking for it. Right? Oh,
C2 is like
yeah, wrong directory. Oh, I'm sleepy. So it might already pull this information. That's what read does, and that's what cache can also be used for.
okay.
Right? So the cache memory, if processes are highly sequential and even highly random at times, the system can configure itself to assign a read ahead value, or maybe some other process that it might require in the next few steps to be stored in the memory space.
Mhm.
Then you will get a cache allocation of the memory, and then the cache will be utilized and it will show up in the used.
Okay.
Okay.
So
Now,
considering this, if we are not restarting a system for whole year, so it will reserve all the memory in
no,
cache.
it won't. No, it won't. It won't. It does clear it at times, right? It automatically clears it. It doesn't go on just storing. It also clears it. Every system has an expiration time that it goes through. If the cache is not being utilized, then it will get removed by the system itself.
Okay.
And it does happen sometimes when you don't restart your systems for a very long time. You see glitches happening, right? Your system slows down, and a lot of things are happening.
Yeah.
And that will lead us to the next topic in the memory space itself. Do we have time? Uh, we have like 7 minutes.
7. Lost it.
We are already over. Are we?
Exact, yeah.
Sorry.
1 to 145, right?
Oh, is Rahul here?
Rahul G is not.
Which
Rahul's
Rahul?
only
Rahul Minglani.
No.
No. Okay. Okay. I'll consume a few minutes of your time, everyone. Is it okay?
Okay.
I have time. Okay.
Others?
But yeah.
Yes.
If you want to apply call session schedule कर सकते हैं.
Definitely we'll schedule another session because it's just part one. मैंने एक स्लाइड बनाई है पीपीटी पे.
इतना जरूरत नहीं है उसका में हम सही नहीं पाएंगे.
You came with one slide.
Yes. I'll give you a small क्या बोलते हैं उसको जो शोज के एंड में आता है अगली मूवी ट्रेलर. So we'll go to the root file system and we'll see one of the most interesting directories that is there. It's definitely proc.
Yeah,
आपकी
okay.
स्क्रीन पे
Huh?
आपकी स्क्रीन दिख नहीं रही.
Yeah, your screen is stuck. Like what you're typing, we are not able to see.
Oh, is it? Is it? Oh my.
It's better if you do it in your local terminal instead of.
No. It's actually my.
Screen. 100 गया.
बड़े भैया ने क्लोज कर दी.
Sachin is speaking Hindi.
बड़े भैया
इमेजिन हम वो वहाँ बोल रहे हैं उनको पता नहीं है वो मीटिंग से लेफ्ट हो गए हैं. Hi, welcome back.
Still its network is like.
Oh. I was speaking on this. My Firefox has crashed. Mm.
Just give me a minute if I can fix it. We can continue, or maybe we can just schedule another session then.
Better to give a tailor of whatever you were going to give in last.
Who killed Katappa?
आप मैं थोड़ा सा क्या कहते हैं वो देना चाहता था ताकि सब लोग थोड़ा सा पढ़ लेना, थोड़ा सा पढ़ के आते हैं तो
ये
इंटरेक्टिव सेशन ज्यादा
थोड़ा
अच्छा होता है.
रिसोर्स भी शेयर करना लिंक
हाँ
I'll just
लिंक्स
get a
सब बना बनाया चाहिए पूरा
मेरा सिस्टम ही क्रैश हो गया. चलो गाइस,
ओके
my system crashed.
थैंक यू बस
utilization.
We'll do it another time.
Utilization looks like went high.
नहीं यार, सिस्टम स्लो है मेरे हिसाब से, इसलिए क्या कहते हैं मैं जिस हिसाब से यूज करता हूँ क्रैश ही होता रहता है. चलिए, okay guys, maybe we could schedule another session, and I'll just type in a single command in the chat section, and you all can actually run it on your systems, and maybe give it a little look. And next time we'll discuss in depth of what's going on with this display. Okay, there's a small command. You can run it on any Linux
बड़ी
system.
इन्फो फाइल नॉट फाउंड
And please do interact, guys. File not found.
नो आई वाज किडिंग या गो ऑन प्लीज
सचिन है क्या?
नेक्स्ट टाइम सेशन से पहले थोड़ा होमवर्क दे देना.
होमवर्क नहीं, इट्स एन इंटरेस्टिंग थिंग. मैंने गलत लिखा है क्या? बड़ी इन्फो होना चाहिए
No, it's correct. I was just
है
kidding.
तो.
Like I executed, it's working fine. Exit code is zero.
Oh, come on, dude.